Everybody, in this video we are going to discuss the concept of a complex number. Okay, so a complex number, not quite real, not quite imaginary, but it's kind of a combination of both. That's why we refer to it as complex, but it does involve the imaginary unit. So we're going to go ahead and get started with the definition of a complex number. We define a complex number as any number of the form a plus bi. Okay, and there are a few things we want to point out about this, starting with this. We have the imaginary unit I. Okay, so we say imaginary unit. And just recall that the imaginary unit is equal to the square root of negative 1. We say a and b, these are both real numbers. Okay, so real numbers. So you'll notice that the a and the bi here, we tend to refer to the first part of this, and so maybe I'll switch my colors here. Maybe we'll go with like a green. But the first part of this imaginary or complex number, we refer to that part as the real part. So this is the real part of our complex number, the real part. And we also have the imaginary part. So like I had mentioned, a complex number is no more than the combination of a real part to an imaginary part, or within an imaginary part. And we say that complex numbers written in standard form, okay, standard form, are of the form a plus bi. So, for example, let's say we had this number here. We tend to refer to complex numbers as, say, like z. We don't have to be really big on that in this video, but we'd say, what if I had a complex number, and the complex number was negative 5 plus square root negative 9. Okay, so of course we need to start by simplifying this and kicking out our imaginary unit because we can't take the square root of a negative number. So this would be the same thing as negative 5 plus, we can throw an I out front and just make this a positive 9 in here. And we know that the square root of positive 9 happens to be positive 5, 3. So we'd get negative 5 plus 3i. Now that being said, we refer to then this 5 as being our real part of this, or the a part of our number. B would be explicitly equal to 3, so we have a is negative 5. B is only equal to the 3 part, and then the I part is just kind of off to the side. But we would refer to this as an individual complex number. Z is equal to negative 5 plus 3i. Okay, so that being said, let's just go ahead and kind of explore some of the properties of complex numbers, kind of like equality. Okay, so starting with this, we can actually say that two complex numbers, start with this, a plus bi is equal to c plus di. Now, we could set two complex numbers equal to one another, but basically what we need to do is kind of lay out the rules here. This would be true if and only if this a here were the same thing as c, and this b were the same thing as d. So basically we say two complex numbers are equal if and only if it is true that a is equal to c and b is equal to d, given this definition up top here. Okay, given this definition up top. So that's just something we need to start by mentioning. It's not something you confront all of the time, but it would be fair to say this as an example, possibly. We could say as an example, let's say I had the complex number 3 plus 2i, and I said this is equal to x minus yi. It would be fair to say then that x therefore is equal to 3, and y is therefore equal to 2, just because of the equality of complex numbers. Okay, so we have settled the equality part of complex numbers. Okay, so we have the definition is a real part plus an imaginary part. We know that standard form, writing a complex number in standard form is a plus bi, and we know that we can equate them by equating its individual parts. Okay, so maybe we'll just do a real quick one here. What if I said I had a series of complex numbers and I want them written in standard form? So we'll say like a, b, c, d, and we want to write these things as complex numbers in standard form. Well, let's go with this one here. How about 4 plus radical negative 16 would be our first number. How about, I don't know, radical negative 4? That's kind of an easy one to think about. 8. 8's a good number, ocho. And, I like this. How about negative 6i plus I squared. You know, it's possible we're dealing with stuff like this. What I want us to do is I want to write these in standard form of a complex number. I want them to be explicitly written as some a plus some bi, okay? And maybe we state what a and b are after we're done with these. So go ahead and start with this first example here. You'll notice that we're not, we have something that appears to be a real part of this number, the a part, but we don't have an imaginary part yet. But this is going to turn out to be it. So go ahead and kind of evaluate or simplify your radical here. This would be the same thing as 4 plus, bring the I out front. This would be positive radical 16 now. And we end up with this, 4 plus 4i, because the square root of 16 is 4. So this would be our complex number in standard form with our a part and our bi part. Okay, so we've nailed that one. So how about b? Now, the interesting thing is this is a complex number. As a matter of fact, I would challenge you to think of a number that is not a complex number. Because any complex number just simply has to have a real and an imaginary part. Well, this one here turns out to be imaginary. We end up with, this is the same thing as I times radical positive 4. We'll just bring the I out front and we get rid of that negative in there. And so we'd say this is okay, then 2i. Now, the thing was, I wanted to explicitly write this in standard form. So anything in standard form, a complex number in standard form, has to have both a real and an imaginary part. So if the question is this, so what's our real part here? What's like our a? If you do not see an a, then we'll simply just define it as being 0, 0 plus 2i. Okay? So this would be the standard form of this complex number, where 0 is our a part and b is the coefficient of our I in this case. Just as likewise down here, is c, we say 8. Now 8 is a very real number. We say it is purely real. This number is purely real. It has no imaginary part. But that's not to stop us from saying, okay, well then this is technically 8 plus 0i, and I kind of rest my case on that one. But we can still explicitly write this in a plus bi form. So now this last one tends to kind of fool people right off the bat, but I'm drawing upon your knowledge of the imaginary unit. That is, again, just kind of maybe list these again. I is I squared, well I squared is equal to -1, I cubed, which is I squared times I, which I cubed, we could say is -I, and then I to the fourth, any number of groups of I to the fourth would just come out to be 1. So drawing upon this knowledge, we can remember that I squared is the same thing as -1. So it would be fair to say when we go down here and restate this, we could say this is the same thing as -6i, just like I have listed over here, plus we know I squared is -1. Okay, so maybe twisting this around a little bit, since addition, well, it's definitely commutative, we could say this is the same thing as -1 minus 6i. That would be the same thing as the original number we started with over here, except for this is explicitly written in a plus bi format. So this is just a little bit about complex numbers, how to equate them, how they're written in standard form, and it's very important that we know how to write every complex number in standard form, because it is very possible that we can write every complex expression in a plus bi form.